So welcome to the last chapter of this course, chapter 12, particular section called Intermolecular Forces. Now, intermolecular forces are different than intramolecular forces, which is what we've talked about so far in this course. So in this course, we have talked a lot about the properties of molecules and lately about the attraction between two atoms and a molecule in the form of either a covalent or ionic bond. So those kinds of bonds, covalent and ionic bonds, are called intramolecular attractions. They're very strong, they're what gives structure to a molecule, and that's why we studied them for a good part of this course. But we should not neglect something that's called intermolecular forces. Those are forces that are between molecules. So when you study, in this case, HCl, you're not just studying one HCl molecule, you have a whole population of HCl molecules. And there is some intermolecular attractions when talking about a sample that need to be talked about, need to be investigated when discussing physical and chemical properties. So that's what this chapter is about. This chapter is discussing intermolecular attractions. These are attractions between molecules, not within the same molecule. And these intermolecular attractions are weak, but they can be really important in determining physical and chemical properties of a substance. One type of intermolecular force we will talk about later on is called the hydrogen bond, which obviously involves hydrogen. But there are four different types of intermolecular forces that we will talk about. But first, let's just say why intermolecular forces, as I alluded to before, they influence physical properties of a substance. So something that has weak intermolecular force tends to result in something that has a low melting and low boiling point. So for example, gases, they tend to have weak intermolecular forces. Things that are liquid or particularly solids, things that have high melting and boiling points, those are substances that tend to have strong intermolecular forces. Intermolecular forces are also important when dealing with gases, even when you are at non-ideal conditions. So if you remember from the previous chapter on gases, if you have a gas sample that's at low temperature and high pressure, those gas molecules slow down in their movement. They get closer together, and therefore the intermolecular forces, or the attraction between those two molecules, is more prevalent and is more important. So that's why we need to talk about intermolecular forces when we deal with gases at non-ideal conditions. And this last bullet point is probably my favorite because since I'm a biochemistry person, but intermolecular forces are really the driving force or the impetus between that make biological processes happen. When two molecules interact to catalyze a reaction, you want there to be an attraction, but you also want that attraction to be fleeting. Okay? So these intermolecular forces drive many biological processes. We're really not going to talk about them in this course, but you will encounter them if you go on in biology or take a biochemistry course. The four types of intermolecular forces that we will talk about in this class are listed below here. They are called dispersion, dipole-dipole, hydrogen bonding, and ion dipole. We will start with dispersion first, but before we start with dispersion, we're going to take a little side review on the concept of polarity and dipoles, because for dispersion forces, and actually for dipole-dipole as well, you need to remember the concept of polarity and dipoles.